Hello there, Mr. Sutton here, bringing you the AB Calculus 3-1 Extra Practice number 2 solutions on the power rule. For this problem, taking the derivative, since we have x to a constant, we can use the power rule. So we're going to have 7 times negative 2 giving us negative 14 for the coefficient, and then drop the exponent by 1, so that's going to be x to the 6th. So negative 14 x to the 6th. On this problem, to find the derivative, it would be helpful to first rewrite these with exponents instead of radicals. So this first one, this is the square root of x to the 11th. I can rewrite this as x to the 11 over 2. There's an invisible 2 there. For this next one, this is going to be negative x to the 7/10. And now I'm going to use the power rule since I have constant exponents. So for my first term, I've got 11 halves times x to the, and now we're going to have to subtract 2 over 2, so this is going to be the 9 halves. For this next one, we're going to have 7 over 10 times 1, so 7/10 out in front, negative 7/10. And then we're going to have x to the whatever this minus 1 is. Well, that means we're subtracting 10 over 10, so this would be the negative 3/10 power. To take the derivative of this function, we're going to first rewrite all of these with exponents and no fractions. So we have 2x cubed, that can stay the way it is. This next one, though, I can rewrite as 3x to the negative 3rd power. And for this next one, I'm actually going to split this fraction up. So I can think of this as 3 over x squared plus x over x squared. But I don't want to write those with fractions. Let me write this as 3x to the negative 2. And then instead of writing x over x squared, well, that really reduces to 1 over x, which is just x to the negative 1. All right, well, now I have to go through and actually use the power rule. These are all constant exponents. So for the first one, this is going to be 6x to the 2nd power. For the next one, I'm going to have, let's see, negative 3 times negative 3 is positive 9. And we're going to have x to the negative 3 minus 1, so negative 4th power. On this next one, I've got negative 6 x to the negative 3rd power, subtracting 1 still. And for the last one, we have negative 1x to the negative 2 power, subtracting 1 from that. No need to simplify or rewrite with fractions, so we are done. For this problem, to find the derivative, I'm going to first rewrite this 9 over x as minus 9x to the negative 1. And now I can just go straight through and use the power rule on each of these terms because they have constants in the exponents. So for this first one, I've got 3/5 times 4, which is going to be 12/5. And then this is going to be x to the, well, 3/5 minus 5/5 because we're subtracting 1. So that's going to be the negative 2/5 power on x. For this next one, I'm going to have positive 9 if I do negative 1 times negative 9. So positive 9 x to the negative 2 because I've got to subtract 1 from negative 1. To make my life a little bit easier on this problem, before I take the derivative, I'm going to first rewrite all of these with just something times x to some power. So this 2x to the 4th, I'm fine with the way that is. But this next one, 1 over x squared, I'd like to rewrite that as x to the negative 2 so that I can use the power rule in a moment. And these radicals and fractions, I'm also going to rewrite these with just normal exponents. So this next one, I'm going to write this as x to the 4 over 9. And for this next one, I'm going to need a negative exponent. So this is going to be negative 5x to the this is going to be negative 1 over 5. And then this 54 is still hanging around, at least for now. All right, so moving on then, we have to use the power rule on each of these. Don't forget to actually take the derivative. You haven't actually taken a derivative yet. You've just rewritten things. So going from left to right, first term, we have 8x to the 3rd power, because 4 minus 1 is 3. On the next one, we have negative 2 x to the negative 3rd power, subtracting 1 from the negative. For this next one, this is going to be 4/9 x to the, let's see, 4/9 minus 9/9, that's x to the negative 5/9. For this next one, we have negative 5 times the negative 1/5. That just cancels out to give us positive 1. And then this will be x to the negative 6 over 5. We're subtracting 5/5. And then finally, this 54 is a constant, so the derivative of that is just 0, and we don't have to write it. For this one, we're just taking the derivative using the power rule. These are all constant exponents, and I don't have to rewrite anything, so let me just go straight through and use that. Going from left to right, this is going to become 4x to the 3rd Next, this is going to be, let's see, 3 times 3 halves, so that's negative 9 halves, x squared. After that, we have 10x to the first, minus, this is going to be 6, because it's the line rule, the constant times the x rule. And then finally, derivative of negative 2 is 0, so we don't write it. On this problem, we're trying to take the derivative of 6x to the b. Now, the important thing to note here is that x is a variable, and we know that because we have f of x here. So that means that b then is a constant. So we have x to a constant, which means we can use the power rule to take this derivative. So we're going to just treat b as a constant. We just don't know exactly what it is. But using the power rule, we're going to have b times 6, so that's going to be 6b, and we're going to have x to the whatever b minus 1 is. Now, since we don't know what b is, we can't really simplify it more than that. We're just going to call this x to the b minus 1, and this is as good as it gets. For this function to take the derivative, going from left to right here, derivative of 7 is just going to be 0, so we don't bother writing anything there. For this next term, we can use the power rule, so this is going to be negative 30, x to the negative 11th, negative 10 minus 1. For this one, we're just going to go straight through here to take the derivative and use the power rule. So on this first one, I have negative 4 over 4, which is just going to cancel out and give me a negative 1. And then we're going to have x to the negative 5th power. On this next one, we've got, let's see, negative 3 times negative 1/3. That's just going to be positive 1, x to the negative 4th. This one we have negative 2 over 2, so that's negative 1, x to the negative 3rd. On this next one we have positive 1, x to the negative 2. So yeah, there's a little bit of a pattern going on here. But then the pattern breaks down here. Derivative of 3 is just 0, so we don't write it. For this problem, we're trying to find the limit as h approaches 0 of this monstrosity. Now the key here is recognizing that they're essentially giving you the IROC form of a derivative, the limit form of a derivative. And all you have to do is recognize what function they're really just asking you to take the derivative of, and possibly what number they're asking you to plug into that derivative. All right, so the key here is we look for the h. Whatever is being added to the h, we're looking for something plus h, and we're just going to substitute x for that when we write out the function. So we see here that we have negative 5 plus h, we have negative 3 times that and the 4th power, and over here we have another negative 5 plus h, 9 times that, and then squaring. And then over here we seem to be repeating the pattern, negative 3 times something to the 4th, 9 times something squared. So our function then is just going to be negative 3x to the 4th plus 9x to the 2nd. So now that we've identified the function that's being differentiated here, we're just going to actually take the derivative using the power rule. I mean, you could do all this out the long way, the really long way, but the power rule is there for a reason. It's a nice shortcut, so let's use it. So this first one, we've got negative 12x to the 3rd, and then this next one using the power rule, this is going to be 18x, much faster than doing it that way. But now we actually have to plug in a number, because you'll notice this is not x plus h, this is negative 5 plus h. Negative 5 plus h, negative 5, negative 5. There's no x's at all. So clearly then negative 5 has been substituted for x up here, which means we need to substitute negative 5 for x in this derivative down here. So we've got negative 12 times negative 5 to the 3rd plus 18 times negative 5. And you could leave it unsimplified, but if you want to simplify this, this is negative 12 times negative 125. Well, what is that? 10 times 125, that would be 1,250. Add to that another 2 times 125, so another 250. That brings us to a total of 1,500. And from that we are subtracting in this term. This is going to be a minus 90. So 1,500 minus 90, that's going to be 1,410.